So, shall we start?
Yes, ma'am, I'm ready.
Oh, a very
Yes.
good morning to you all. It is my great pleasure to welcome you here this morning to this third day online global faculty development program organizing by Department of CSC VJIT. A warm welcome to all. Now I request Dr. Siddhartha Ghosh, Head of AI, that is Artificial Intelligence Department, for a formal welcome.
Thank you, Divya, for giving me the opportunity. And also, I welcome DeepShare AI and the team for this today's session. And as all of us know, like for all the participants who are participating here from the day one, that you are aware that this specific faculty development program is for artificial intelligence and data engineering. So just maybe 1 minute or 2 minutes, I'll try to take a major point here that most of the data analysis as well as in the higher level data science task is basically depends on the part data engineering. An expert says that the 80% of the task of data is hidden in data engineering because as long as the data is not in proper format, as well as is not properly filtered, the necessary things are not out, you cannot use the data and even it may misguide you. So I'll be requesting all the participants to take the best from this, what you can call session, the best out of it. And today you have the session on machine learning applied, time series data analysis, and predictive analysis applied in planning, budgeting, and forecasting. So please get settled and enjoy the session. I thank CSC department and Divya for giving me the opportunity. Have a good time. Thank you.
Thank you, sir. Today we have Durga Prasad. Let me briefly introduce him. He works with DeepSphere Artificial Intelligence, Architect and Data Solutions. He also focuses on large-scale implementing various enterprises. He is deep expert in data analytics, worked with various clients. He also completed Bachelor of Technology in Engineering and MBA. My passion is building a career and empowering the future of ordinary people through practical coaching by offering hands on expertise across multiple technologies. To date, I educated and empowered more than 10,000 plus individuals and 50 plus organizations in the field of enterprise, artificial intelligence, and data engineering. Dear all, you guessed it right. I welcome Mr. Jyoti Periyasamy, co-founder of Deep Sphere Artificial Intelligence in cooperation with Palo Alto. Welcome you, sir. Now I request you to guide us and to lead us into a practical session. Over to you, sir.
Thank you, ma'am. So this tells me you read my LinkedIn.
Yeah.
Yes, thank you very much. Uh, Even though I do a lot of things, but teaching is my real passion. Correct? Like, um, as a, I would say, industry expert, I worked in various industries, a lot of different roles. Like I worked for KPMG, Ernst & Young, Deloitte, whatever client you name. Like, a lot of top tier clients I worked. Different roles, different people, different things, but I still enjoy teaching. So that's my true passion. Without any hesitation, if I have to pick a career to move on in my life, that's my going to be teaching. Thank you. All right. So we are in day 3. So I put day 2. Day 2 was like, I thought it's just my day 2, but technically we are in day 3. Tomorrow is going to be last day. So today, what we are going to focus on, how do we truly apply machine learning, correct? So we talked about it. I'm sure there's a lot of presentation that you may have attended, but let's understand. I know in the 90 minutes, we may not be able to do hands-on, but I'm open in case in the future, if you want to do hands-on, we can. So this is going to be a live demonstration kind of a session. And that is why Durga Prasad here. So we build the model, we trained and deployed the model. Okay, so this is the actual model has been implemented end to end. It It's a real problem that I'm currently working on as a project. Okay, so I'm going to take this as a base, correct, and walk you through anything, everything that involved. So what exactly it means, taking the concept, what you learned, how do you apply in a practical problem solving? Because artificial intelligence as a concept, we all know, as in a subject we have studied in the past. But what is lacking or what is missing at this point? How do you apply to solve practical problem? Okay, I think that's where everything's challenged. I have to say this, surgery can only done by a surgeon. That means, so when we have an expertise doing surgical procedures, we would be confident to do surgical work. If it is not, we won't be able to confidently go out and say, I am doing surgical work, right? So what it means, the more knowledge you gain, the better you teach for the students. The better you teach for the students, you make them very highly marketable, talented, empowering leaders in the future. Okay, the future is this, correct? No matter what it is, correct? So, sorry. Today's session is going to be very hands-on. So that's one of the reasons that I have Durga Prasad in case I run into problem, I can use his laptop as a backup to run this demo. It's going to be very hands-on. There's a lot of things that practically how it works is going to be taught in the class. With that said, let's move on. I did talk about DeepSphere in the last session, so I'm not going to repeat this one actually, so I'm going to skip this. We talked about B and DP. Okay, so just a small recap. What is artificial intelligence by definition? It's nothing but creating intelligence artificially. Okay, so what kind of intelligence we are creating? Anything that a human does, those are all intelligence. Okay, those are all intelligence. What a human can do, driving, cooking, medical diagnosis, coding, programming, all such things can also done by a machine. So we want to use, sorry. So we want to use artificial intelligence to create such intelligence artificially. Okay, that's what we are going to focus on. So what is it we can do from industry perspective? There are two things. Don't worry anything else. Whatever people talk, ignore that. Okay. So using artificial intelligence, you can do only two things. You can build an intelligent automation or you can build data science. That's it. Rest all has to come under any one of this. Okay. So using artificial intelligence, what we can do. Either, I'm talking strictly on industry perspective. Either you can build an intelligent automation or develop data science. What is an intelligent automation? An automation works by itself. A self-driving autonomous car, okay? The car works without a driver. Okay, such automation, what industry is looking for. How do you implement or how do you build that? That's what the focus of intelligent automation. Second, I'm not automating, but I really want to discover deeper inside the data, correct? So traditionally we run reports, but now I want to go beyond a report. What exactly you want to do? I want to dig deeper, find out what is hidden insights in a data set. That's a data science. These are the two things you do. How we can implement this one? So we talked about in the last, the only way you can make this happen, you teach the machine. How do you teach the machine? You go for machine learning. Okay, that's what it is. Okay, that's what it is. Rest all, correct? Probability, statistics, mathematics, decision tree, random forest, all will come later. Okay, so as a concept to understand how we can implement the intelligent automation, data science kind of thing, use machine learning. What we are trying to do, teach the machine. Got it. Okay, so in terms of creating artificial intelligence, okay, in what form we can create artificial intelligence, correct? In what form? When I say what form, applications. What kind of application we can build? We can build simple applications. We can build complex problem, okay, solving complex problems. Or we can solve problems around images, videos, voice. We can also solve problems around language processing. We can also solve problem around business processing. Okay, so what kind of intelligence we can create? So these are the 5 different area of type of intelligence we can create. All of them uses the machine learning. Okay, all of them uses machine learning. Okay, so this is just a recap of what we did so that we can set the expectation and move on. Okay, how do we teach the machine? Okay, how do we teach the machine? So if you look at, there are 5 different applications that we could build. We can develop simple models, simple algorithm using supervised, unsupervised reinforcement. Yesterday, Dr. Geeta was talking about a lot of these things. As needed, I can touch, I can go any extent, any level, any deep as needed, but I have to focus on today's session. So the machine learning goes across the board. Okay, so don't think machine learning means just only machine learning. Okay, so basically what it is, you're teaching the machine. That's what machine learning. What is it you're teaching? If you're teaching a machine to learn about images, that's computer vision. If you're teaching a machine to learn about languages, that's natural language processing. If you're teaching a machine about a business process, that's robotic process automation. Okay, that's robotic process automation. If you're teaching a machine to solve very complex problems such as cancer diagnosis, okay, or discovering deeper about a patient readmission rate, those are all problems quite complex, large data sets involved. Such problems you will teach the machine using deep learning models and techniques. The problem is simple, it's not quite complex, and easy to work with the data sets. In such cases, you are teaching the machine either using supervised, unsupervised reinforcement learning. Right? So these are the core learning pattern that you choose to teach the machine. Either you teach the machine to learn the images, or you teach the machine to learn about languages, or you teach the machine to learn about business processes, or you can teach the machine to learn about complex algorithms, complex problems, or you can teach the machine to learn simple problems, simple algorithms. Okay, so the end product, what it comes out, the end product comes out an algorithm. Okay, the end product comes out once the machine learns, it creates an algorithm. Okay, it creates an algorithm. I will share the slides so you can take a look and you can understand. So one thing I can tell, you don't find this kind of constructed information or slides in anywhere else. Correct? People talk so many things, you will get confused. You have no idea what is machine learning, what is computer vision, what is artificial intelligence. Even if you ask people, there are so many confusion around the machine learning and artificial intelligence. Right? So this is basically a level set for all of us to be in the same page. Okay. There's one more topic that I want to talk, data. Okay, so what kind of data we are going to work on? Okay, what kind of data we are going to work on? Okay, 1 second. So typically, okay, when we are talking about teaching the machine, data plays very dominant role. Okay, as the head of artificial intelligence at VJIT told, data engineering plays a key role in terms of implementing artificial intelligence. Okay, when people say implementing artificial intelligence, you could immediately think of implementing an intelligent automation, data science, an intelligent automation or a data science, or it could be both. To build something at that magnitude in the real world, you will be working with all kinds of data. Okay, and that is the biggest challenge right now. Okay, there are different type of data that's going to be involved. I'm sure all of you know what is the structured data. If a data is stored in a table with rows and columns, it's quite easy to read and write. Okay, it's quite easy to read and write. If data is not structured, like when you go to Facebook, when you go to LinkedIn, when you go to Twitter, correct? People write anything they like. There is no structure, there's no table, there's no column, and that's why it's unstructured. Working with that kind of data, it's quite challenging. Why? The way you write is different than the way someone else writes. The way I write is different than somebody else writes. There's no structure there. Since there is no structure, reading and processing such data is going to be quite challenging. All right, semi-structured. Take an example of email. Typical email has what? There's a subject, there's a content, there's a signature. Typically, not everybody does this one. Someone sends email without a subject, someone sends an email without signature. So that may or may not be applicable in the context, but most of the email follows some structure. But the body could be anything you write. Okay, so that is what is semi-structured data. Then you have videos. Okay, when you go to YouTube, there are so many videos out there. When you go to any other places like Facebook or Twitter, people can post any pictures there and voices. So in a real practical world, okay, in a real practical world, data could be anything. For example, one of the project that I'm currently involved, conversation-based customer engagement. When a customer comes into a store, okay, the store camera sends the customer to the system, a digital boardroom. In the digital boardroom, the customer picture will appear. A machine will speak. Welcome, John. How are you doing? Okay, we have this promotion going on. In that one, I have video and I have an image and I have voice. Can you believe that goes to all the way to a CRM system where I can pull customer information. So when a customer comes into the store, I can, through camera, I can take the customer face and do a facial detection and identify whether the customer is a known customer. Yes, it's a known customer. So Dr. Divya is known to us, this store. And I will go and check in the CRM what kind of thing that this customer bought last time. And this is what the customer bought last time. And then I will bring it to the digital board and tell, hey, this is what you bought last time. And we have some promotion going on this one. That is the level of automation we are doing. So what is it called? Conversation-based customer engagement. Okay, you don't have to do anything. Okay, you don't have to do anything. So that's still in a pilot. When you go to a retail store, they understand if you already been to the store. From your facial, they do anything, everything that's involved. In that case, all data that what is listed here involves. There's a video, there's an image, there's a voice, there's a structured data, which is CRM. There's unstructured data, what the customer likes on the Facebook, and etc. So like this, data become very key component of implementing artificial intelligence. Okay, so what I'm trying to say, if someone asks you, what are the different data that we need to train the machine? Typically, data required to train the machine depends on the problem that what we are solving. But here is the different type of data that's used to train the machine. Okay, so you as a teacher, when you teach to the student, you have to make sure the students understand in a real world practical problems involves all this data together. How do you make this data available for the model to run? And that is what data engineering we are going to touch tomorrow. Okay, in tomorrow's session, we are going to talk about volume, frequency, validation, modeling, pipeline, etc. Okay, so this is just an introduction. All right, so this is basically sets a level for across the board. So now we are getting into time series data analysis, predictive analytics applied in planning, budgeting, forecasting. I have a question. Let's make it very interactive. Okay, how many of you are aware of planning, budgeting, forecasting? I know you all understand predictive model, no question. Okay, I am also known that you know data analysis very well. There's no question. Time series, I didn't say you are the masters. So how many of you understands or know about planning, budgeting, forecasting? Anyone? Can any one of you give me your understanding? Okay, so don't feel bad. No one knows everything. Okay, there are things I know well, there are things I don't know. Correct? So I can even speak about it. So whatever you know, can anyone tell, so that I can set the stage in such a way that you understand the basis. What is planning, budgeting, and forecasting? Why these three comes together? Any thoughts? I am sure you all in some form involved in this process. Okay, curriculum design. Okay, curriculum design, faculty development. Okay, what is this? These are all part of planning process. Okay, so can anyone tell your understanding about planning, budgeting, forecasting, and why all these three come together? Any idea? Come on, I need someone. No one? Is this because your phone is mute? I can unmute you. No volunteer. Very sad.
Sir, there's an answer from G. Kalpana. Planning means resource planning, budget means cost planning.
Sure. First, I want to appreciate Kalpana stepping forward and telling this one. Actually, I like it, but it needs more insights. Correct? You use the word resource planning. That's basically like part of human resource, headcount planning, labor forecasting. All comes into that one. Um, no question. What you said is right. Anybody else? Okay, let's move on. So this is where industry comes into picture. Okay, this is where industry comes into picture. Let's understand. You see, if we don't know what is planning, budgeting, forecasting, then how do we actually work on time series? Okay, time series is exclusively for planning, budgeting, forecasting. Okay, time series is exclusively for planning, budgeting, forecasting. Okay, but it's not only for that. You can do a lot of other things, but when you touch planning, when you touch budgeting, forecasting, there is a time series involved. There is a time series involved. Without time series, you can do this one. Absolutely, no question. Okay. So at the same time, like one question, okay, in any enterprise, okay, whether it's a small enterprise, medium enterprise, large enterprise, what department do you think common across the board? Okay, whatever the departments, okay. So even including university colleges, you take university colleges, what would be the department common across the board? I'm not talking computer science. I'm not talking about mechanical engineering. Okay? Some university may have, some university may not have. Across the board, what department it's common in small, medium, large enterprise? Any thoughts? Any idea? Anyone? Anyone? Kalpana. So can you tell us across the board, what department it's common, okay? So what I'm talking about, when you go to a company, okay, Tata Consulting Services is a bigger company, okay? There may be a local smaller company in Hyderabad, okay? So it doesn't matter what size of company it is, or what kind of organization it is, there are some departments common across the board. So for example, you take every company has a finance department. Every company has a human resource. That's common no matter what it is. Okay, what size your company is and what business you do, it doesn't matter. Okay, it doesn't matter. For your university, there is a controller who controls, not the exam controller, finance controller, okay, who controls the budget. For your university, also there is a human resource who deals with people issues, okay, who deals with people issues. So what I'm trying to say, this function of planning, budgeting, forecasting, don't think it's for finance. It's common for every department. What Kalpana told, planning for resources. Okay, what kind of resources? How many faculties I need for 2021 for artificial intelligence? How many faculties I need for data science? How many faculties I need for data engineering? And what is that? That's a planning. Okay, how do you know? Okay, how do you know that? You analyze the data. What data? Time series data. Okay, time series data. So the point what I would like to make, the planning, budgeting, forecasting, it's just not only for finance. Don't think that way. It's common across anything what you are trying to do. Okay, anything requires a planning, budgeting, forecasting. Let's move on. So some basic knowledge about time series. I don't want to spend too much time. So if I wanted to find out number of enrollment, okay, year 1, year 2, year 3, year 4, okay. So there's some typos. I need to correct this. So year 1, year 2, year 3, year 4, and 5. So that's basically like, tells me in year 1, how many people enrolled in the computer science department, electronics department, IT department, okay. So I'm trying to correlate data between the enrollment and the year. Here you see, okay, I have a time component, and basically that represents the number of enrollments, okay? That's represented along with the number of enrollment. So if you look at data at this level, you can see there's a time series involved, okay? There's a time series involved here. The time series here represents the equal interval of time on a data representation, okay? On a data representation. So what's the equal interval? It could be yearly, it could be quarterly, it could be monthly, it could be weekly, hourly, minutes, seconds, any extent you could go, okay? Any extent you could go. So taking data in a time interval, analyzing this further is the time series analysis. Like I said, I don't have to teach this one, you all master in this one. But the point I wanted to make, what we analyze here, past, current, and future, okay? Past, So whatever happened in the past, that's past. Whatever happened right now, whatever happening right now, that's current. Future, what's going to happen next year. So past data analysis. So what are the students and faculty ratio for 2019 Maths, Physics and English department? Okay. So in 2019, how many students we had, how many faculties we had, okay, the ratio. So that's one kind of analysis. That's 2019. In 2020, I want to find out how many students are still pending under payments, okay, in the month of June or July, okay. So how many students are not paid their fees? I want to find out that, okay. And who has not submitted assignments? So that's basically current for this week, okay, who has not submitted the assignment. So that's basically the current analysis. Future. So how many faculties I need to teach artificial intelligence, computer science, okay, part of computer science department or artificial intelligence department. I need faculties who can teach these things. Data engineering faculties, data science faculties. I also need faculty who's going to teach AI. That's for future. So what does this means? Indirectly it represents planning, budgeting, forecasting, okay? So this type of analysis, which leads towards, you create a plan. What is the plan? How many faculties I have to hire in 2021 to teach data engineering, data science, artificial intelligence? To bring those faculties, what is my budget is going to look like? Okay, I'm going to bring someone from MIT. How much I have to pay? This much I have to pay. And how long this is going to be? It's a full-time role. I have to pay this much. Okay, so that's my budget. Forecasting. Okay, so what is forecasting? We will talk about this one. So point what I would like to make, the time series analysis will lead towards creating planning, budgeting, forecasting. Okay, using time series, you can analyze current, past, and future. Okay, you can look at past and go back and look at, in this case, we are looking at and telling that in 2019, okay, what is the ratio between the math, physics, chemistry faculties and the students? Okay, so that is 2019. In 2020, in the month of June or July, I want to know how many students paid the fee or not paid. Okay, that's the current. And also I want to know how many students submitted assignment, not submitted. Okay, so these are all current things. Future, I'm talked about. All right, let's move on. So now, what is the dependency? How does it work in the dependency level? Okay, what dependent what? So if you see here, when I do planning, I look at the actuals. Okay, based on the prior year, I do some planning. Okay, that's manual work. Okay, so look at how much money we spent. Okay, how much we spent for computer science department in the year of 2019. Take that and add 10%. That become the budget for 2020. Okay, or do some Excel spreadsheet. You do this one. Forecasting. What do I do in the forecasting? I look at the plan and see how the plan is performing. Correct? Is it up to the look at the actuals and see what the actuals look like, and based on how the actuals are, then I'm going to make an adjustment. That's become the forecast. Correct? We will do. We'll have an example. Understand. So the point what I'm trying to make, the planning depends on actuals. The forecasting depends on your actual and planning. Okay, actual and planning. All the three will lead towards budget. Okay, all the three lead towards the budget. Okay, so what is actual? We'll take a look right now. I have an example. Okay, I have an example. We'll take a look. So planning, how many faculties I need to teach data science, data engineering, artificial intelligence in 2021. I'm planning for it, but I have not hired those faculties. So in order to hire, I need budget. How much budget I'm looking for? So there's a dependency between planning and a budget. What is the forecast? Okay, so I'm supposed to hire 4 data science, 2 data engineer, 5 artificial intelligence faculties. Okay, so 4 plus 5 plus 2. So almost 11 faculties I'm supposed to hire in 2021 by June. Did I hire? No, I'm not. Why? I don't find qualified faculties. How many I hired? I hired only 5. So now you see there is a variance. Okay? You planned something, it didn't happen. Now I want to make an adjustment. And that adjustment is what? I'm doing forecasting. I'm doing forecasting. Anyway, we'll go. So now we kind of understood what's actual, what's planning, what's budgeting, and forecasting. Okay, so these are the dependency. The planning dependent on actual. The budget is depends on actual, planning, and forecasting. And forecasting depends on planning and actuals. It's really interesting to understand. Okay, you cannot plan without a baseline actual data. Okay, without a baseline actual data. And what is the forecast? Forecast is nothing but adjustment to the plan based on your actuals. Adjustment to the plan based on your actuals. Budget, in order to achieve all the things. Okay, in order to achieve all the things, I need a budget, and that's what that is. So here is a simple example. Okay, here's a simple example. So what I have right now, students' fee collection by month and by department. Okay, so in the top you see I have January to December 2020. I have departments here. If you see January, February, March, April, May, so those are all actuals. The fee has been already collected. How much I collected in the AI department, IT department, CSC department, correct? So these are all my actuals. Okay, these are all my actuals. And June is my current. June is my current. July, August, September, October, November, December, that's my planned fee collection. Okay, that is how much I'm going to collect. I planned for it. Why? If you don't have this one, you can allocate budget. Okay, if you don't have a plan, you cannot allocate a budget. So point what I wanted to understand, when we say time series, in this case, I'm trying to create an Excel spreadsheet, which basically lists all the department, all the month, and how much I collected as a fee from the students. Okay, so if I look at from January to December, January I already collected, February collected, March, April, everything's collected. Those are my actual fee collection. That's called actuals. That's called actuals. So actual represent a event that's already took place. Current, that's happening right now. Okay, current, that's happening right now. June is my current. Planned, it is not really happened. It's going to happen in the future. It's going to happen in the future. So those are the futures. July to December, the fee that I'm going to collect is the futures. That's the planned one. So you know actual, you know planned now. Okay, let's move on. So now if I move on to forecasting. So what I'm doing here, if you see here in June, in July I have 100K, 90K, 110K, 90K for each department. Artificial intelligence, 100K. Okay, then 90K, 100K, like this, correct? So this is still in a plan. Now, as of today, let's assume today we are in July. So now what happened? June become actual, July become current, and this is the forecast. August to December is the forecast and collections. What does this mean? I'm going to make an adjustment. Okay, so why? I'm looking at this. Okay, I'm looking at this. All the actuals from January, February, March, April, all the way to June, and July is current. I see my fees are not coming through. Okay, my fees are not coming through. So here I have a planned fee, and here I'm making an adjustment to this one. So this adjustment, what I'm doing is nothing but my forecast, and this is the predicted value. This is the predicted value. How am I predicting? In a simple case, I'm looking at all the actuals and see in what rate I'm getting. Okay, in what rate I'm getting this. So that is basically my forecast. Again, on the top you see time series. Okay, so we are talking actual, we are talking plan, and we are talking about forecast. So forecast is nothing but, so here it's 100K. When I come here, that 100K become a 90K. Why does it become a 90K? Because based on the actuals, how much I'm collecting, I'm changing this one. It's a predicted value, the value that has been forecasted. Okay, it's a forecasted value. All right, how do we allocate budget? Okay, in this case, I have actual, I have forecast. Okay, I have actual and forecast. So basically, what it is, I take this one. How much money each month I spent? Okay, and this is my forecasted fee collection. Okay, how much I collected, and this is a forecasted collection. So based on these two factors, I'm going to allocate budget. Again, it's a predicted value. This is not a budget that is you're ready to spend. Okay, this is not a budget that you're ready to spend. It's a budget that you're going to allocate. You're going to ask for it. You're going to request this kind of allocation of a budget. Okay, this kind of allocation of budget. So point one to understand, I'm doing a prediction here. Point two to understand, I'm doing a prediction. So what am I predicting? So in a typical case, you do planning, that's also prediction. You do forecasting, that's also prediction. You do budgeting, that's also prediction. Okay, so these are all predicted value. Okay, and all of this value works on a time series. Okay, works on an equal interval, and every month. The interval here is monthly. The interval here is monthly. So this is the idea behind of time series data analysis for planning, budgeting, forecast. Okay, let's move on. So what are we predicting? Okay, in this case, we are predicting the future fee collection value, budgeting value for the future expenses. Okay, budgeting value for the future expenses. Okay, so what I'm predicting in this case, I'm predicting the future fee, how much I'm going to collect. Second, based on the fee that I'm going to collect, I want to allocate budget. okay, for the expenses. So in order for me to do, what are the different data set I need? Okay, to do this one, what data I need? In a simple case, you can look at fee collection of 2017 and budget data for 2017, 2018 fee collection and 2018 budget data, 2019 fee collection, budget data. What do you call this one? These are all your historical data. These are all your historical data. Is this enough? Of course, if you don't want to take any other chance, yes, that could be enough. Okay, the model is not going to say no to you, but it won't perform well. Okay, it won't give accuracy. What also matters, like take the current situation. Okay, I don't think any student is willing to pay a fee at this point. Why? The situation is like this. What is that? So that is not your historical data. Okay, that is not your historical data. It's a global event. Okay, global event. Okay, what is the current event that takes place? In the current state, due to COVID-19, a lot of people are unemployed. A lot of people don't have money to pay. A lot of people not even like interested to go to school or colleges. Kind of like they're like kind of depressed. They don't want to go. Okay, those things also matter. Okay, so what I'm trying to tell, don't think you are planning, budgeting, forecasting always based on historical data. Okay, it's not always based on historical data. So the historical data, what you have, it's time dependent. The data what you are going to get from outside and external data. These are all your historical data. These are all your external data. So the data that what you are going to get from outside, and those data are not, may or may not be in a time series. This is where data engineering comes into picture. How do you integrate these data with your time series data? Okay, so when we say time series, data has to be in an equal interval. Okay, either it could be monthly or it could be quarterly or yearly. We don't know at this point how long the COVID-19 is going to continue. That's not a time series, correct? How many people is going to die in the June, July, August, September? We don't know that. Okay, we don't know that point. How long this is going to go? Is it going to end in 2021? Okay, we don't know that. So we also need to consider some external data which will make the model to learn very well, which will give higher accuracy, higher confidence level. So what, for an example, I have put local current event data. Let's say in Hyderabad, there is some curfew. Okay, so people are fighting each other, they're killing each other. So that could be something that put in a difficult spot, no one to move around for the next 2 months. Something bad happens. Okay, I wish nothing happens, but something happens. That's a local event. That's not a global event. So you do need that kind of data. That has an impact to the fee collection. If there's a curfew, the students are not going to come for school for next 2 months, then you can't collect anything from the students. You can't ask them to wire you because they're not coming to the school. So that has an impact. So you have to also consider that one. Global event such as COVID-19, it's unplanned event. Okay, so you have to consider that kind of factor as well. And also industry, as a company, as an industry, how it's doing now. Like for example, oil and gas, correct? Since no one's driving the car, correct? Is everything shut down. So how do you sell oil price? It's just disaster. Okay, so all this kind of data matter. So what I'm saying, there's no clearly defined definition. These are the data you need. Okay, it all depends on the problem. It all depends on the problem. So point A, in the context of student fee collection, what data we need? For sure, we need historical data. In 2017, how many people paid and what's the budget we spent? In 2018, how many people paid, how much paid, and what's the budget we have? 2019, that's a historical data. Take the data and combine with an external data such as local market condition, local location conditions, global conditions, business, industry conditions, etc. So take all of them and try to come up with a state. All right, let's move on. Let's give one more simple example so that you can understand what's planning, what's budgeting, forecasting. And a hypothetical example. I live in Sacramento, California. I want to go to San Francisco. Okay, how much time it takes from Sacramento to San Francisco? It's 2 hours. Correct. So this is my plan. Planned start time. I want to start at 10 a.m. My travel duration 2 hours. Okay, planned arrival time 12 p.m. Distance 100 miles. So what is my budget for gas, toll, and breakfast? It's about $100. Okay, this is my estimate. So I want to travel from Sacramento to San Francisco. Okay, it's a simple way to understand the planning, budgeting, forecasting. In order for me to go, I have to do a plan. What time I'm going to start? I'm going to start 10 o'clock. How much time it's going to take me to get there? 2 hours. Does that mean what time I'm going to reach? I'm going to reach at 12 p.m. PST. Okay, how much the distance? 100 miles. What's my budget to drive the 100 miles? I need $100. Okay, got it. So now I'm traveling. I'm driving my car. after 1 hour, due to traffic, an accident, I'm not able to travel what I planned for. After traveling 1 hour, how much distance I travel? 25 miles. So now I'm doing a forecast. Why? Because I plan to travel only 2 hours. But within the 2 hours, am I going to reach the current condition? No, I'm not. What is my current condition? Due to an accident, there's a heavy traffic. Because of the heavy traffic, what happened? I was not able to travel what I planned for. I traveled only 25 miles. How many miles left? Still 75 miles. So do you think I can travel the remaining 75 miles in 1 hour? Impossible. So now I'm going to do forecast. Okay. So what I'm going to forecasting at the rate of 25 miles per hour, how much time is going to take for me to reach San Francisco? Okay. So I'm going to do forecast. Okay. So I'm going to arrive instead of 12, I'm estimated forecasted arrival time is 2 p.m. PST. And also now, since I'm traveling more than 2 hours, I need to eat lunch. Now my budget is changed. Instead of $100, now my budget become $125. Okay, now budget become $125. So here, what is impacting me? The traffic and accident. What is it? It's an external event. It's impact to my plan. So because of that, okay, when I do forecast, I have to consider external factors. Okay, I have to consider external factors. So these are all impossible for a human to do, and that is why we need machine learning. That is why we need artificial intelligence, correct? That is why we need artificial intelligence. So that can scan all the global thing that going on. Okay, the coronavirus may not be severe in Hyderabad, but it could happen. How do you know that? You have to study the coronavirus data sets, okay? Study them, understand how fast it's spreading, under what condition it's spreading, and what weather it is spreading, and who's the target. Is it a male or female or aged people? Okay, if it's like aged people, then school students may not be get affected. Okay, so you may be getting the payment later, but still you have some delay. You have some delay. So like this. So when you do forecasting, you have to consider external factors. Okay, you have to consider external factor. In my case, I'm supposed to travel 2 hours due to an accident, which is an unplanned event. Okay, that happened local. It's an external. It's beyond my control. It impacted the whole thing. So now I have to forecast, which is going to take more time for me to get there. And I also need a budget. Okay, why? Because my travel got extended. Now I have to eat lunch. Now my $100 budget become $125. Okay, so this is just a simple example for you to understand how the planning forecasting has an impact on external data, and it's a continuous process. Okay, it is not a once you're done or done deal. You have to do this every month. You have to do this every month or every year or every hour. We don't know what it is. That is why it's called time series. That is why it's called time series. So in my case, I can do my another forecast after 30 minutes. I will see where I am, correct? Whether I need more time, whether I need more money, I can do that. Okay. So point is, all the things you have to consider when you do time series analysis. Okay. So this is another example. Okay, so that you could understand. So what is a rolling forecast? Have anyone heard the name rolling forecast? Okay. I'm not asking you what it is. Did anyone hear about rolling forecast? Did any of you hear about rolling forecast? What is rolling forecast? Any idea? Did anyone hear about rolling forecast? No? All right. Let's move on. So what is rolling forecast? It is nothing but, okay, it's a continuous process. Okay, it's a continuous planning. So for example, where we are right now in June. In June, I'm forecasting for July, August, September, October, November, December, 6 months. So when I'm in July, I'm going to for another 6 months. So now July is my current month. I'm going to forecast for next 6 months. When I'm in August, next 6 months. Okay? So if you see here, so this is how typically people do planning, budgeting, forecasting. Okay, 6 month rolling forecast. Okay, so 6 month rolling forecast. So by definition, forecast is nothing but an adjustment, a predicted value which adjusts the planned value. Okay, a predicted value which adjusts the planned value. So here, it's a continuous planning, budgeting, forecasting process, and this allows you to forecast it for 6 months from the current period. When you're in June, you forecast for next 6 months. When you're in July, you forecast from there to next 6 months. Okay, August from there to next 6 months. Okay, the 6 months is basically like typically industry standard people use for planning. Okay, so what is my planning is going to look for in next 6 months? Anyway, that's fine. So I wanted to make sure you understand all the things we are going to use the machine learning to solve this one. Okay, so we are going to use machine learning to do planning, to do budgeting, to do forecasting, and also do rolling forecast. Okay, so that's what we're going to talk. But before that, you have to understand all the things. Okay, all right. So now we are coming into real world problem. So before we go there, I want to make sure any question, planning, budgeting, forecasting, how it works, and what is 6-month rolling forecast. Is that clear? Is this clear to you all? One confirmation. Can anyone confirm, please? Do you understand planning, budgeting, forecasting? Okay. Okay, so no silence means I assume it's understood. Thank you. All right, let's move on. Okay, so now we are getting into a real world problem. How do we apply this in a real world? So this is the actual project that I'm working on. It's an actual project that I'm working on. So I took that as an example. I'm trying to walk you through. So what we are doing right now, so we are basically trying to predict how much this particular product to sell in a region, in a country, in a city, correct? So that is basically one of the things that what we are trying to do. It's more on revenue. Okay, how much this particular product we are going to sell, okay, in a given region, country, etc. So what to predict? Sales quantity. At what level it takes place? SKU level. What is SKU? Stock keeping unit. That's the lowest level. Okay. At this level, we have been asked to predict the sales quantity, how much we are going to sell by customer in a given region. Region could be North America, country could be India, city could be Hyderabad. Okay. At that level, we have to go and see how much we can sell. Correct? That's a predictive model we have to build. So how does it brought into, like, hierarchically? So when I say SKU here, what does SKU stands for? Stock keeping units, correct? How does it hierarchically represents? So we had a product family. Example, hardware is a product family. Under the hardware product family, we have different product group. Then we have the product, then we have the SKU. Okay. So an example, product family could be hardware. Product could be a printer. The product could be a specific printer, in this case, HP 9000 color. SKU for the printer, what I can sell, tape, ink, etc. So here, the company organized its products hierarchically as shown below. And it has 25 product families, 50 product group for a family, 75 products per group, per product groups, and then 100 SKUs by product. So this is basically a complex product mapping so that you could understand what exactly it means. The budget could be done at the top level, but all the things will roll up. Okay, so I don't want to scare you. It's quite complex or anything. So this is just to give you a real world example. Okay, so here the business wanted to plan at the SKU level, the lowest level. The budget will be done at the top level. Okay, the budget will be done at the top level. So for this entire family, how much I'm going to allocate? Okay, for the hardware, I'm going to spend 1 million. And what is the sales I'm going to get? That's what this is. So this is basically tell you that at a hierarchically how this looks like. Okay, so what the real world problem? For a given SKU, we need to predict how much we are going to sell by country, region, country, city. Region could be North America, country could be India, city could be Hyderabad. In Hyderabad, how much I'm going to sell this printer, or how much ink I'm going to sell, how much tape I'm going to sell. That is what they ask us to predict. Okay, move on. Okay, so now they also ask us, we want to analyze the data. I really need some input from you. Okay, I really need some input from you. These are all things you know. So what they told us, using the data, we want to do trend, we want to look at seasonal, we want to do cyclic, we want to do irregularity. What exactly this means? Okay, so number one, they told, build something like this and do forecasting at the SKU level, planning, budgeting, for planning and forecasting at the SKU level, budget at the top level. Now, the budget, that's one of the requirements. The second requirement, They also wanted to analyze the data. Okay, in what form? They want to analyze the data in a trend, seasonal, cyclic, irregularity. Okay, any idea what it is? Okay, any idea what it is? For example, when you look at the time series data, when you flat a graph, okay, we are going to see that. When you flat a graph, so the data will represent in any one of this form. Okay, in any one of this form. Trend. So what is the trend today? Oh, the coronavirus, number of people in the coronavirus is going up. That's a trend. Okay, the trend is going up. The trend is going slow. Okay, it's going low. So you see what people are saying. So that is basically a representation of time series. Okay, they look at the data. What was the case yesterday? What was the case day before yesterday? What was the case last week? What was the case last month? You compare that, you see a trend. Either the trend can go up or the trend can go down. So business wanted to see, implement this one and also build a model which represents a trend, which shows me the trend in the data, which shows me the data in the trend. What is seasonal? Okay, what is seasonal? So maybe the coronavirus thing could go away when we have, like, summer very hot weather. Okay, summer very hot weather, this is going to go away. So what does that mean? During the time, correct, the number of cases could go down. So that's a seasonal, correct? There are some products, like take an example, ice cream. Ice cream may sell well in summer. In winter, ice cream may not say well, okay, sell well. So that is the pattern I want to see in a time series data. So what do you call that? That's seasonal. Cyclic, it's kind of up and down, up and down, up and down. It goes up, it goes down. So there's no trend here, okay? It's cyclic thing. What is irregularity? Okay, irregularity is something like coronavirus. It is an unplanned event. We didn't know that. Okay, we didn't know that. All of a sudden, something bad happened. Okay, I want to see this in the data. So, ladies and gentlemen, understand this is the key essence what business want to do. Okay, they want to analyze the data and discover the trend, discover seasonal, discover cyclic, discover irregularity. Okay, so this could be your plan, it could be your budget, it could lead towards your plan, budget, and forecasting. Okay, so all the three will lead towards forecasting. So I would encourage, understand this better. Okay, so understand this better. So these are the things in a real world. Business want to look at the time series data and discover the trend, discover the seasonals, discover the cycling, discover the irregularities. Okay, they want to discover this one. And that is why we need machine learning kind of thing. As a human, we wouldn't be able to do this one. It's impossible. There's no way we can do this. As a subject, we can study, but practically going and implement, you need army of people, correct? We need army of people. So that is where we really come and use machine learning. Okay, let's move on. Okay, so the business wanted to implement, okay, number one, a sales planning, forecasting, budgeting, which is revenue. They also wanted to understand in the data set, what is the trend, what's the seasonal, what cyclic patterns that I look for, irregularities. Okay, so this is kind of, we talked about it, like, what it is. This indirectly lead towards, okay, this is lead towards build, planning, budgeting, forecasting. Okay, that's what I'm talking here. All right, so now what I want to do, okay, so I wanted to basically take all the things what I studied, okay, what I studied. It's getting to a point, how do we implement this as an artificial intelligence solution? Okay, I did discuss this at the beginning of the class. Can anyone tell? Okay, if I have to implement artificial intelligence, there is only two options. Option A, build an intelligent automation. Option B, data science. My question to you, if you understood, if you follow me so far, you can tell now. So that's why I put the question mark here. Okay, so in order for me to implement what we discussed, okay, so what we discussed, the business, what they want to do, they want to discover trend, seasonal, cyclic, irregularity in a time series data, which is basically looking at planning data, forecasting data, budgeting data, discover all of those. They also want you to predict in terms of how much revenue I'm going to make. That means how much I'm going to sell a particular product in a region, country, city at a SKU level. Those are the things they ask us to do. To implement that, what I have to choose. Can I build an intelligent automation or a data science? Correct? As I said in the beginning, you cannot implement artificial intelligence just like that. It has to be very structured, methodical. So it could be either implementing an intelligent automation or a data science. My question to you, which one we are going to implement here to solve this problem? Any thoughts? Do you think we need to implement data science, or do you think we need to implement the intelligent automation, or both? Any thoughts? Any thoughts? I hope you understand my question. Do you understand my question? So to implement artificial intelligence, we have to choose either building an intelligent automation or data science. So what I'm asking, I explained what is the real world problem that business asking us to do. So now I'm asking, to implement the real world problem, what type of artificial intelligence we have to implement, either in a automation or data science, or both.
So there's an answer from Bhikshapati Peruka. It's data science. And another answer
Excellent.
from Fantin, both.
Uh-huh.
And someone raised hand, Mr. Rangaswamy. Can you please unmute and answer your question?
Okay.
It's automation and intelligence.
Okay, intelligent automation, you are saying.
Yeah.
Is that correct, Dr. Ranga? Intelligent automation.
I think so.
Okay, wonderful. First of all, I want to thank and appreciate all the participants who answered this question. So it is both. So it is both. I can't solve this just by data science. I can't solve this just by building an intelligent automation. I have to implement both. So this is what I would say, the thought leadership that you have to gain. Okay. So this is where you really help students to understand how they can take a problem and translate into a solution. Okay. All right. Thank you so much. I really appreciate it. All right. Let's move on. So in order to implement this, I have to build an intelligent automation and also build a data science. Let's move on. So now I have two options. I also have a question here. Please listen to this. Correct. So now that I have an option to implement intelligent automation, I have an option to implement data science. So what I'm doing to build an intelligent automation, I'm leaning towards building a machine learning model. Okay. I'm leaning towards building a machine learning model. Okay. Building a machine learning model. Second, to build data science, I'm using a statistical data analysis approach. Okay, a statistical data analysis approach. It's called SRIMA, stands for seasonal autoregressive integrated moving average. Okay, moving average. I am very sure a lot of PhDs in this class who studied maths really well. I know Dr. Ranga done a PhD in mathematics. He can speak more about it. I may not be well qualified person, but the point what I'm trying to ask you, to implement intelligent automation, I can go with the machine learning, building a machine learning model. To go for data science, okay, I can use statistical data analysis. I don't have to use the machine learning, build from scratch, correct? Build from scratch. So I explained what is SRIMA stands for, okay? It's basically pre kind of a trained model, which is ready to go. You don't have to build anything, it's already there. All the things what you need, it's there. You don't have to build from the scratch. So what I'm asking here, what is the difference between there's an ARIMA, there's an SRIMA. That's one of the assignments. Maybe you can email me or you can email to Dr. Divya. Second, what's the difference between linear regression and SRIMA? Okay, so in order for me to go and build an intelligent automation, I'm leading towards the machine learning. What kind of machine learning I'm taking? Linear regression model. Why did I choose a linear regression model? I'll explain. Where does this come under? Okay, so if you look at one of the slides that we talked about, computer vision, natural language processing, robotic process automation, I didn't choose computer vision. I didn't choose natural language processing. I didn't choose deep learning. I didn't choose the other options that I had. So I chose a simple machine learning model, which is in this case a supervised machine learning model. Okay, so these are the two questions. I want you to get some clarity and mail me or respond to me in whatever way you wanted to. So in yesterday's class, Dr. Geeta was talking about there are different type of problems we can solve. So what are the different type of problems that we could solve? Okay, she talked about classification. Okay, what is classification? Basically trying to predict whether this is male or female, yes or no, 0 or 1. Is it going to happen or not? Correct? So that is kind of classification. Second, she talked about a regression. What is a regression? So regression is not 0 or 1, true or false, yes or no. Regression is a range of value. What is the salary of Divya? So Divya could make 50 to 75 lakhs, correct? What is that? That's a range. What is the salary for Dr. Ranga? As a HOD of computer science department or AI department, he makes 1 crore. His salary could be 75 to 1 crore. So what is that? That's a range of value. Okay, that's a range of value. So that is what it's a regression. So when it's a classification, the value could be either 0 or 1, true or false, yes or no, male or female, etc. It's a classified values. When you have regression, it is not a classified values, it's a range of value. So in our case, the sales that what we are going to predict, it is not 0 or 1, it is not yes or no, it is not true or false, it's a range of value. So that is why I chose linear regression model. And this is a supervised machine learning. Okay, so I want you to think through, understand how we are solving this problem. To solve the problem, we have to build an intelligent automation. That means an automation occurs without a human intervention. An automation occurs without a manual intervention. Second, I also want to build deeper data analysis. Okay, when I say deeper data analysis, looking at all the things such as local market condition, global market condition, impact on society, impact on economy, impact on many things, correct? Go deeper. How do we do all the things? That is what seasonal does. That is what seasonal does. So I can use a statistical modeling tool, which is already available, ready to go, SRNO. I have 2 options, okay? So let's understand how do we implement one at a time, okay? I don't know whether I have time to cover all of them. I'll try my best. I'm going to start with the option 1, then I will go back to option 2. If needed, we'll cover touch base tomorrow. But I want you to think about all the things, correct? I really wanted to think about, correct? All the things. If you're looking for a textbook, I am very clear. There's no textbook which can teach you at this level. There's no material out there we can get to at this level of details to teach you, okay? All right. At a high level, what is the architecture behind the scene? This is just a high level, you could ignore, okay? So we have source, we have data lake, we have data provisioning, I have predictive analytics, model outcome, okay? Again, these are all just for information, ignore this one, okay? So what is the technology that we are going to use in order to build this one? So we are going to use data engineering technology, we are using AI technology, computing technology, correct? At a high level, I'm talking about, correct? Again, for this session, it may not be applicable except Python. Okay, so what we are going to look at, it's going to be built on Python. So I'm talking about Anaconda, I'm talking about a Conda package manager, and there's a tool that used for data engineering, there's a tool that used for building models, there's a tool that used for computing, correct? So if you really want to get to real world, all the things matters, correct? Without this, it's just like, watching something that we have no idea where it's going. We have to understand this one. In some form, you don't have to be hands-on. You don't have to be an expert, correct? In some level, you need to know what technology we need to do data engineering, what technology we need for model engineering, what technology we need for computing, correct? So how do we connect all the things, correct? Not just standalone. It should be fully connected, end-to-end integrated, okay? All right. This is just a landscape, how it's going to look, how the production is going to look, pre-production development is going to look. It's just an idea. In the real world, how it's going to look, okay? All right. So before we dive into the actual demo, there are certain implementation terminology that is being used. I want you to understand. So how do we start this one? Always start from a problem statement, okay? In order to implement a machine learning model, okay? So that's what we're talking about. Okay, we're talking about linear regression, okay? Supervised machine learning. You always start with the problem statement. Yesterday also someone asked a question, okay? What data I need? Data is going to be identified based on the problem. Once you know the problem, then select the model that what you want. So in our case, what we are trying to solve, we are trying to solve a 6-month rolling forecast, okay? We are doing a 6-month rolling forecast on what? On a revenue. And also we wanted to basically give a platform for user to analyze trend, seasonal, irregularity, and also cyclic patterns. So that is my problem statement. In order to solve this, I'm choosing a model. What model I'm choosing? Linear regression, okay? If there's multiple model, list this one. We talked about problem type, correct? The problem type, either it's a classification or a regression problem. So in our case, it's a regression problem, it's a range of value. All right. Then the technology selection. We looked at the technology. Data collection, data preparation, provisioning, okay, all the things, okay, I will cover in the next session. Okay? Ignore this right now. Tomorrow I'm going to focus on. So once I have problems ready, now I have to train the model. I have to test the model. I have to look at the model outcome. I have to validate the model. Okay. Once I validate the model, I'm going to deploy the model. Once I deploy the model, that means my model pipeline is ready. And see how the model is performing. If the model performs well, that's fine. If it doesn't perform, retrain, retest, revalidate, redeploy, continue to monitor. So this is how you implement. Okay, this is how you implement. Correct. So starting from the problem statement, select the model, do the technology selection, and set up everything. Ignore data for now, which we will cover tomorrow. Okay, which we will cover tomorrow. Then once your data is ready, then start with model training, model testing, model outcome, model validation, model deployment, model pipeline, model retraining, retesting, revalidation, redeployment, continue to monitor the model. Let's understand what each one is. I'm sure we talked about what is model. Okay, so we talked about the models. Random forest could be one of the model. Logistic regression could be another model. So it could be a machine learning model or it could be deep learning model, etc. So model means that is what the statistical modeling that we are talking about. Training and testing, it's a critical step. Okay, each one will have its own data. Okay, each one will have its own data. Basically, you teach the machine. Okay, that is what the first step. Okay, so that is what the first step. You teach the machine on what the machine is supposed to do. Okay, you teach the machine what the machine is supposed to do. Once after you teaching the machine, test whether it's doing or not. Okay, whether it's doing or not. So what am I going to teach? I'm going to teach the machine to predict a revenue for a particular product at a SKU level in a region, country, and city. In a region, country, and city. All right. So once the model is trained, the model is going to create an algorithm that's called learning algorithm. The model is going to create a learning algorithm. So the algorithm is nothing but data patterns. Whatever it does, okay, that's been trained, known. The model creates the algorithm, which is in a traditional software engineering is source code. Okay, it creates that one. Once it's done, then you verify the model. That's a model outcome. Then the model validation. Okay, so how do you validate the model? You create a validation data sets and run the model again and verify and confirm. If everything looks good, okay, that means you are done with the model. You analyze the model, and model analysis is nothing but so how the model is performing in terms of accuracy, confidence level, and everything, and see how it performs. And that is the analysis. Once you analyze, the model pipeline has been fully built. When I say model pipeline, what I'm talking about, this one, end to end. Okay, the entire thing is work. Correct? Data lake, data provisioning, data predictive analytics, model outcome. Correct? So you see this one, the entire pipeline is working very well. That's what I'm talking about. Correct? So when I say model pipeline, it's a critical steps. So model training, model testing, model outcome, model validation, model analysis, all working fine, good to go. Okay, so good to go. I selected the model, I trained the model, test the model creates the learning algorithm. I tested, I looked at the outcome, I verified, everything looks fine. I built the pipeline, which is what this. Okay, what is the deployment? Where do we put this one? I can put in a development or in a quality system or in a production system. It depends on where you want to deploy, it goes there. Okay, so I'm going to skip this one, training data, data provisioning, data validation, data pipeline, that we will cover in the next session. Okay, that will be covered in the next session. So one point I would like to highlight, in a traditional approach, we don't do anything, right? In what you teach for the students right now, you don't teach for model training, model testing, model validation, model outcome, model analysis, model pipeline, none. I don't think you are teaching this one. Maybe the artificial intelligence department may be teaching. The traditional computer science or IT, I don't think that I have seen them teaching them. So what I'm saying, there's a change in what we teach for the students. Okay, so this is basically the change I'm highlighting, the traditional versus AI approach. All right, so let's move on. Okay, so there's one more key thing that what people may ask you, what is a future engineering? So future engineering, yesterday Geeta madam was talking about it. Okay, so now in order for me to solve the problem, I have a data set. Okay, I have a data set. I have a training data, I have test data. For example, in our case, so what we have a training data, we have a test data. When I go here, I have training data. When I go here, I have a test data. We're going to look at it. Okay, in the training data, so what is my goal? Okay, my goal is basically trying to predict something. So what I'm going to predict, okay, I'm going to predict the quantity that I'm going to sell. Okay, the quantity that I'm going to sell, you see this one, what I'm going to predict for, the quantity that I'm going to sell at a SKU level as well as a product level. In order for me to teach the machine, I have to give a lot of information. See, I told I'm going to go by region, by country, by city, okay, at this level, by customer, and that's also products, okay, product group, product, family, SKU. So this is basically all the features that I'm going to give the model. Okay, these are the features I'm going to give the model. So the model need to understand. Okay, so what kind of information that I'm giving? Okay, what kind of information that I'm going to give so that it learns and understands. Okay, it learns and understands. So this is basically in a way it's called features, hypothesis to arrive something. Okay, hypothesis to arrive something. So for example, what does this represent? So this represents your historical data. Okay, this represents your historical data. So what I have done, I'm just going to take this and put it here. Okay, okay, hold on. You see this one? What do you call these things? The country, region, city, state. So this is what features. These are the features will lead towards predicting these two values. The value that I'm going to predict, it's only these two. Okay. So what I'm going to predict, I'm going to predict product quality and the quantity of the product that I'm going to sell, SKU at sell. At what level? At this level. So what do we call all these things? So this is my features. So we have to extract all the things, okay, from the data. And that is what we call feature engineering. Okay, that is what we call feature engineering. This varies by problem. Okay, there is like, a lot of discussion around this one. Like I said, in a 90 minutes class, I won't be able to discuss a lot more, but I'm just trying to give you an idea. I want you to understand what I did. I looked at my training data. In the training data, I wanted to know in order to predict something. Okay, so what I'm going to predict, I'm going to predict this. Okay, I'm going to predict this. So to predict these values, okay, hold on. So to predict these values, what is the feature I need? So I'm going to predict two things. One is the product quality. So the quantity of this is what I'm going to predict. Okay, this is what my prediction. So to predict these two, okay, I have to have all these features. I want to know by region, by country, by product, by SKU, what I'm selling, correct? So these are all called my features. These are all called my features. It's not a rocket science. You just have to understand, okay? And this varies by problem. This varies by problem. This is not just common across the board. Whatever problem you take, okay? So this is identifying the future need to predict something or to arrive something, to solve something is called features, okay? It's the features. So in our case, this is what features, okay? This is the features. So what I did, I looked at my training data. In the training data, I have everything that's modeled to learn and understand the patterns. So the model has to predict two values, which is basically the quantity of these two guys. This is the value that model has to predict. So for that, I have to train the machine. To train the machine, I have a training data. This is my training data. In the training data, the field that what I have or the characteristics which determines something is called feature engineering. Okay, it's called feature engineering. So engineering is basically extracting all these things, but feature is nothing but this is what features. This is what feature. And this is basically my target output. Okay, this is my target. This is my target. So the quantity of the product, the quantity of the SKU is my target. Others are my features. All right, let's move on. So second point, what I want you to understand, data validation, model validation. How do we verify the model? Okay, in the machine learning world, people typically follow this approach. They take the data and put it in a curve, okay, in a graph. So based on how the model performs, you can understand what it is, okay? So there are three different options: regular fit, underfit, overfit. Yesterday, Geeta Madam was talking about it. So let's understand. So now my model is ready. My model is predicting, it's giving an outcome. How do we verify this? Whether it's performing or not, okay? Very simple. So you take whatever your target that you're trying to predict and create a graph like this, right? So what I'm trying to say here, so I wanted to find out the quantity and spent, okay? So quantity and spent, okay? So let's take a hypothetical example, okay? Let's take a hypothetical example. I have a house to sell, okay? I have a house to sell. So the estimated value of the house, it's about 100,000. Okay, the estimated value of the house is 100,000. Okay, how? That is my test data. Okay, that's my test data. I know for sure, correct? This house can go sell for 100,000. Okay, so this house can sell for 100,000. So now when I run a predictive model to predict the price of the house, so now I take the outcome and put it in a graph like this. If the model predicts the estimated price, because it's my test data, I know what the value is supposed to be. Okay, it's my test data. I'm testing the model. When I do the testing, I can create a graph like this. When I create a graph like this, based on how the model predicts, I will know whether the model is predicting regular, under, over. Okay, regular, under, over. Regular fit, under fit, over fit. What is regular fit? It predicts exactly what you expected. Okay, it's close to predicts what you expected. The house price is supposed to be 100,000. Yes, it does very well. Awesome. That's regular. But the house price is 100,000, but model says 75,000. That's underperforming. Okay, it's not predicting well. It's not predicting what you expected. The third, the house price is 100,000, but the model predicts about 200,000. That's a overpricing. That's a overpricing. So you take your test data, run the model, and see how the model outcome comes in the form of a graph. Okay, in the form of a graph. If it is basically like, if the expectation is 100,000, if it comes close to that, that's basically a regular fit. If it goes below, then it's underfit. If it goes above, it's overfit. So your target 100,000. If it is predicts somewhere close to that, that's a regular fit. Your target is 100,000, but the model predicted 75,000. That's below. So that is underfit. If your target is 100,000, but the model is predicting 200,000, that's overfit. So from industry perspective, so people use this methodology to verify how the model is performing in terms of prediction, accuracy, confidence level. So maybe take this as an assignment, find out the difference between what is prediction accuracy, what's prediction confidence level, and what is prediction weightage. Correct? These are all matters. Correct? Accuracy, confidence level, influencing factor, and weightage. I'll write it here. Okay, I'll write it here. Do as an assignment so that you will know exactly what is involved. So model prediction. Okay, one is, hold on. One is model prediction, model prediction accuracy. Second, model prediction so one is the model prediction accuracy, and second one is confidence level. Okay, so how do you determine that? Okay, how do you determine that? What is the confidence level? What is the accuracy? So model confidence level, model influencing factor. So what data influence the model to fail, or model to underperform, model to overperform? Influencing factor. So spend some time trying to understand these three things. Okay, it's kind of related to this one. So when you test the model will give you confidence level, the model will give you accuracy, the model also tells you the influencing factor. Under this factor, it performs regularly. Under this factor, it overperforms. Under this factor, it underperforms. Okay, so it is all based on data. Okay, this is not a difficult thing. It is based on data. It's completely based on data. Okay, so this is based on the data. Okay, this is based on the data. Okay, the training and test data based on the data. So it's primarily training data. So that means if the model is not performing well for whatever reason, you could imagine the training data is not that level. Okay, it's not at that level. Okay, so I want you to think about it so that you can understand. Let's move on. We still have to cover a lot. So, okay, the next topic that I wanted to understand, people talk about hyperparameter tuning. So based on your testing, when you do model validation, you can understand if it's a regular perform, no problem, you move on. The model is not doing a regular performance, it's doing either under or over perform. How do you fix it? And that's when the hyperparameter tuning. So one is you can look at your training data and see how it is. The training data is good, it looks everything nice, no problem. So now you can go back and look at some of those parameters, model parameters. For example, if you're running in a random forest, look at number of trees, number of leaves, correct? And adjust those things. So change the parameter of the model and see how it performs, correct? So these are all part of the testing process, okay? These are all part of the testing process. So once the model is ready, so you can run the model and see where it falls. And after that, go back and look at the accuracy, confidence level factors, and see if the training data looks good. Yes, it looks good. Then go to the next step. When the model is not performing, do a hyperparameter tuning. Okay, so look at the model parameter and try to tune and see how it performs. So that's the way to fix the model. Okay, all right. Now, how do we implement this? Okay, so this is where the system comes into picture. So what I'm going to do right now, so I'm going to do the system level demonstration. Okay, the system level demonstration. So the system level demonstration is here. Okay, so I'm going to open this one. So what you're looking at here in a full scale model implementation. So it starts from step 1. Okay, it walks you through every step that's involved. Correct. So I'm just going to correlate here. You see step 4, you see step 5, and step 6. Train the model, test the model. Whatever I talk, it's here. Okay. So this was coded by our friend Durga Prasad. So he's in the call right now. So you see step 1, you see step 2, you see step 3. Okay, you see step 4. Okay, you see step 5, you see step 6. That's what I'm going to talk right now. Okay, that's what I'm going to talk about. At a high level, what is he talking about? INI file. Don't hard code anything in program. Okay, use an INI file. It's easy to change anything. Okay, easy to change anything. So that's what it is. So high level implementation of the linear regression. Okay, so create an INI file, import the required libraries. Okay, so what kind of library we are using? So there are so many different libraries available. Either you can use Google scikit-learn, TensorFlow, like this. There are different libraries available. So you can see importing the required libraries, correct? So here you can sklearn, scikit-learn. What is that? So that is nothing but, so you can do a Google, you'll get to know. You can do Google, you'll get to know. That's a machine learning library. Instead of you reinventing wheel, Google is already done. You can use them. So that is where the linear regression model is there. Okay, the linear regression model is there. Pythons, what is that? That's a data framework. It's a Python. So this is coded in Python. Okay, this is only Python is possible. There are other languages also you can use, but we feel comfortable to coding in Python or in Scala. So this is coded in Python. Okay, so that is the first step. So the first step is basically set up the import all the libraries. Then the next step is import the training data. Okay, so let's go to the code block and see what it is. Okay, the next step is importing training data. The training data, for demo purpose, I saved everything in local. You see this one? User, Jyoti, desktop, FTP, and training data. So let me open this one. So that's the file that I've opened here. Okay, let me close this. So when I go to my folder, so let me close this too. So I know we are running late. I'll try to finish up soon. So when I go to my desktop, this is my desktop. Under the desktop, this is the folder. Here is the training and the training data. That's what this is. Okay. So this code block, what you see here. So I'm trying to import this training data. Okay. I just opened this one. So let me go ahead and open this. Okay. So the training data, what we need, it's here. Open this guy. So here I talked about it. So what is it has? It has the kind of historical data. Okay, this is my historical data. So what it basically tells you. So how much product I sold by country, by region, country, city, product and SKU, all the things, correct? It has the training information. We talked, I'm going to close this one. Okay, all right, no problem. Okay, let me close this. I don't have to save this one. All right, so now I'm done with step 3. What is my next step? The next step is, once I'm done with this one, import the time series model. So when you go back to the code block, that is step number 4. Okay, so you can scroll down further. So these are all data processing. So this is basically import the model. Okay, so what is this one? he already declared at the beginning. Okay, at the beginning means the sklearn library. Okay, so here he declared the war model here. Okay, so this is basically, so somewhere it's declared, and what he's doing is implementing linear regression. Okay, see this one. So that's basically the model that we are implementing. Okay, so that basically the model has been implemented. So that comes under step number 4. Once you done this one, the next step, which is train the model, then import the test data, run the forecasting, write the model outcome. Correct? So all the steps are here. Okay. So considering time, I'm going to quickly run this one. Okay. All the steps are there. As needed, I can send you the code. So how do I run? So what you're looking at, it's a Jupyter notebook. Okay. It's a Jupyter notebook. So I'm going to go ahead and run the model. Okay. I'm going to go ahead, run the model. I'm going to clear everything, reset first. Okay. So that's what I'm doing. So now, before that, I want to delete the model outcome. Okay, I want to delete the model outcome so that you can see. Okay, so I'm going to go ahead and delete the model outcome so that you can understand it predicts and creates this one. And we will look at that. Give me 1 minute. So the model outcome stored in a specific folder. I'm going there right now. So here, the folder is output. These are the files. I'm going to delete this. Okay, I'm going to delete to make sure actually it creates everything. So these are the outcomes it creates. Like I said, there are several different output prediction involved. As we talked about, there's a prediction of planning, forecasting, everything it predicts, budgeting, all involved. So I deleted all the files. Now will I go back to my folder and show you there's nothing there. Okay, go to File Explorer and look at desktop, look at FTP, look at output, there's none. Okay, nothing is there.
Sir, sorry
So
to
now,
interrupt you.
yes,
We
ma'am.
can see only the slide. If you're running anything behind it, we can't see anything, sir. And only the PPT is on the screen.
Oh my God, how do I change that?
You just stop screen sharing, sir. The top.
Okay, I did that.
Yes. Then you can share the complete screen, desktop screen.
Okay, share computer sound. Select window or application that you want to share.
Yeah.
Which one select? Share computer and sound.
Your wish, sir. In between, if you're minimizing or running multiple tasks, so it is better to share your desktop screen, or else you can share only the compiler screen.
It's not letting me to share. Actually, I'm clicking the share button. Okay, let me try one more time. So share screen. Only host who can share it. It says it's
Okay, sir. Otherwise, I'll make you host.
okay. Can you make me host?
Yeah, I did, sir. Please check once again.
Okay. All right. It is not letting me to share anything. Can you take control, you share, and then give it back to me?
Sorry, sir.
Can you take the control, you share, and then give the control back to me? Can you take the control, share your desktop, after that, give me back the control as a host? How is that? Ma'am, are you following what I'm saying?
Here the option is not to. I mean, there's no option of sharing desktop, but it is showing only the screens which I opened.
Okay, host. Okay, share whatever you can actually. So can you share that?
This photo I just shared now.
Okay.
Now
So
I'm
okay, now give the control back to me.
after stopping, sir.
Yes, ma'am. stop and make me as a host.
Done, sir.
Okay. Select a window or an application that you want to share. Okay, I'm selecting. It is not letting me to share anything now. So let me disconnect and rejoin, okay? 1 second. So ma'am, I'm going to rejoin one more time. I'm going to disconnect and rejoin.
Okay, sir.
Give me 1 minute, I apologize.
Dear participants, sorry for the inconvenience. If you have any queries, you can post in the chat box, or else in between or whenever the speaker asks you to answer some questions, you can unmute. So you have a privilege where you can unmute your microphone and speak something, or else you can raise your hand, virtual hand, so that we made you to unmute self. So I hope you're following the instructions which are posted in the chat box. Thank you. So,
Ma'am, I'm back now. Yeah, can you give me the control?
Sir, I'm making you host.
Okay.
Done.
All right. Okay, so I wanted to choose. There's no option to choose desktop.
Oh, yes, sir.
So what should I choose? Everything?
The applications which you have opened.
Okay, if I open a different application, it won't come.
It comes, sir. Whatever the applications you have opened, everything appears. From that, you have to select.
Okay, 1 second. This is very strange. All right, so I'm going back now. Can try to share. Okay, so I'm selecting. Can I select all?
Sir, you select one first, sir. Let's see.
Okay, all right. So can you see now?
Yes, product level forecasting.
Yeah, so I was trying to compare the PowerPoint into the source code. Okay, so that's what I was trying to do. Okay, so it looks like no one's seen this particular screen, correct? This is a Jupyter notebook. Have you seen the source code that I was talking?
Yes, yes.
No, not now. Before I was talking.
No, sir.
All right, so I have to repeat this now.
Yes, sir.
So what I talked about it, like, how do we implement this in the actual programming, correct? Like, how do we actually implement this one? So there are several steps involved. Step 1, set up an INI file. Step 2, import the required libraries. Step 3, training data and time series model. And then step 5 and etc. Correct? So these are the things what we talked about it. So now I'm going to my source code. If you're not able to see, please let me know. So this is my source code, correct? This is basically what we have written to implement this one. Can you see the file now?
Yes, sir.
Okay, so the same thing what you have seen in the PowerPoint. You see, there's a step 1 INI file configuration. Step 2, required library to be implemented. So what I told, so there are several different machine learning library available. So what we are using scikit-learn. So that's from Google. And that's one has a linear regression. That is the one has a linear regression. The next is training data. Okay, so have you seen the training data, that the Excel file that what I opened? Not yet, or did you see that Excel file?
No, sir. We didn't see.
Okay, so can you see the Excel file now?
No, sir. You have to share it.
Okay, so that means I have to go back and share. So how about now? Can you see anything now?
Only the code.
Okay, now?
No, sir.
Okay. I'm not sure how to make this work. We put so much effort to create this, not coming this way. When I stop sharing, it's not letting me to give the control back again. Actually, that's another problem. All right, I may have to live with this and move on. All right. So step 3 is implementing the training data, bring the training data, and then the next step is basically it talks about how do we bring the model. This is the model import. Then train the model, test the model, correct? The code block, run the forecasting, and then write the outcome. And there's various levels, SKU level and different level. Okay. So I'm going to quickly run this one so that you could understand how it works. And then maybe the next session we can run this one. How do we run this one? Okay, so there are different options. I'm going to select first to clear everything. So I'm going to kernel, restart, clear output. It clears everything. Okay, it clears everything. Okay, so how do we confirm? You can see there's any output sitting here. There's no output here. Now I'm going to go ahead, run all. Restart, run all. Yes, it's going to run all. It's going to create an outcome file, but unfortunately, I won't be able to see the star. That means it's running here. So you will get to see the outcome. You will get to see the outcome. The model is running right now. It performs everything. Okay. So all the steps that what we talked about in the PowerPoint, it's performing all the steps. Okay. It performing all the steps that what we want. Step 1, step 2, step 3, step 4, 5, 6, 7, 8, 9. Okay. All the steps. So those are the steps it's performing. So let me go back and see if written the outcome is written back here actually. Okay. So you can see the outcome is there. Okay, see this one. So rolling forecast. So it's kind of writes the outcome in between the code block and also writes the file. But unfortunately, you are not able to see the files. Okay. Okay, 1 second. I will see if we can see the files. You see the outcome. It's written here. Region, country, state, city, customer, product, family, product, group, product, SKU, time, and the predicted value. So it writes everything. Same here, correct? You see this one? This was not the case. Now it's writing. So you can see them if you are able to see this. So this is the file that I deleted. It's here. So this is the output files. This is the folder output. I deleted this one. I reran this one. It created these files. Okay. It created these files. So basically what we have done. So we were able to create a forecasting based on the product level details that what we got. So what we got actually, so at a higher level, so this is what given to us. So the SKU level, we wanted to predict what we can sell. And that rolled into product group, and family. It does automatically. Second, based on that, the data that what we have, it created trend, seasonal, cyclic kind of analysis where we can go and look at it. But unfortunately, my desktop is not letting me to go and open the file and see all the things. It's not happening. Okay, it's not happening. So in summary, what we have done, we were able to successfully implement the linear regression model. Okay, we talked about 2 options. Option 1, implement a linear regression model, which is a supervised machine learning model, which falls under an intelligent automation. Okay, an automation performs by itself. I don't have to tell what to predict. I don't have to tell so what kind of data that it need to use to learn. It's all completely controlled programmatically. Okay, no human intervention, no manual work. The machine learns, understands, it does the prediction based on what it sees. This one. So this is the model we implemented. So this also we have. I don't think we have time. So it's already we crossed the time. Maybe if I have some time tomorrow, I will cover. But the only thing that what makes me worry, so you are not get to see the model outcome, which is something that a key part of to understand. But the technology what we have is limiting us. Anyway, so that's all I have at this point. I'm open for any question. Correct? So we built an end-to-end model, okay, at an enterprise scale to implement a revenue forecast, okay, at a SKU level by region, by country, by city, okay, by region, by country, and city. And also we were able to create a 6-month rolling forecast and see the trend, seasonal, cyclic, irregular patterns in the data sets. Okay, we have done those things. And this part of an intelligent automation, and we used linear regression, a supervised machine learning to achieve this one. So the best way to learn, do this by yourself. Okay, do this by yourself, you will get to know. And we covered a lot of terminologies. It's really important to understand. Really important to understand. What is model training? What is model testing? What is model analysis? What is model pipeline? What is model deployment? Model validation. Okay, all the things very important. Hyperparameter tuning and regular fit, underfit, overfit. Okay, all these are really key important terminologies. I would encourage you to learn more. I would encourage you to study more, understand. If you have any question, ask me. All right, any question? Any questions? No questions? Come on. All right, thank you. Madam, back to you. Thank you so much.
Thank you, sir. So once again, I would like to ask the participants, if you have any queries, kindly switch on your mic and ask.
Yes, I like questions.
Sir, can I take the control back?
Yes, yes, ma'am. Yes, ma'am, you can. You can. Any other questions? So when we have no question, that means you understood really very well. You have you are kind of mastered what we discussed. Is that how I should be taking, or what is that I'm supposed to be taking? All right, that's fine. I was just
Okay. Sir, the assignment what you have given, I posted in the chat box, and I also shared your
sure.
email ID. So probably you may get emails from the active participants.
Sure.
Thank you, sir. We felt that the explanation was very good and we could understand everything and all the questions in the middle of the session, and many real world applications you have shared in between, and you have answered the queries as well. And you have made us to understand the real world applications, how things are working, how we can work out and all. And thank you so much for taking your time to prepare for us such an extraordinarily wonderful presentation. Someone has raised, can I see you once again?
Can I see once again?
Someone
What is
raised
that?
their hand for query.
Sure, yeah, please bring it up. Like I said, I love questions. I like challenges. I like debates. So I'm not a good debater, but I'm learning.
Miss Radhika. Radhika, madam, you have anything to say?
It's a very nice session. We had a crisp and clear understanding of the concepts. Thank you, Mr. Jyoti. It was very nice.
Thank you, madam. I really like this encouragement. It makes me very energetic. It makes me work very hard. You cannot believe, since morning, this is the only thing I was doing. I had a lot of material, but I wanted to make sure actually, it flows well. It touched to the point, because all the things what I thought it's more US students, I have not touched the Indian type of academic professionals. So I spent the whole day today to figure this out. And I asked DP to prepare everything. Unfortunately, the system didn't cooperate. Otherwise, we could have seen that the end was a good step. Anyway, that's fine. Thank you, ma'am. I appreciate that.
Thank you. We'll also work on it, and any questions in our next session, we will definitely ask. Thank you so much.
Ma'am, if we could find out how do we share a desktop, that would be great, because that was limiting me today. Otherwise, it would have been a wonderful session.
Okay, we'll work on it. Thank you, sir.
Thank you, ma'am. Thank you all. You take care. Bye-bye.
Now I request Dr. D. Aruna Kumari Madam, the Professor of CSE Department, to speak few words. Aruna Kumari Madam. Yes, ma'am. Ma'am, your mic is on.
We can't hear you, madam.
Dr. Aruna Kumari Madam, your mic is on. Please speak. We can't hear your voice, ma'am. Sir, the participants are asking if you have any videos or materials for the discussed topic. Can you please share?
Um, sure, ma'am. I will work on it.
Okay.
Yeah.
So
So one thing I can comment.
Yeah.
These topics is not self-learning, ma'am. Like, it is not that easy to follow. Like I said, I constructed in such a way that, like, it makes you to feel that it's flowing well. If this is going to be a self-study, it would be very difficult.
Okay.
Yeah, there are too many moving parts. Like, so I have business problem, I have model, I have data, I'm connecting all, I'm trying to get the flow going. At the same time, connecting to system, demoing, all. Like, I'm just saying, this is not a self-learning material, at least in my view.
Okay. I think from Dr. Aruna Kumari Madam, there's a
Yeah,
problem.
I have, yes.
Yeah, ma'am,
Now,
we can hear you.
thank you so much, sir, for your valuable session, Jyoti sir. And also, we would like to thank all the participants for participating in this workshop, 4-day workshop. And even in this lockdown time also, because of our resource persons' effort only, we were able to, we are continuing our learning skills. Thank you once again, sir. I invite all other participants for the next tomorrow's session. Thank you, sir.
Yeah,
Thank you,
please
Divya,
attend.
for giving me this opportunity.
Thank you, madam. Please attend tomorrow's session. And I would say there's no one in industry teaching data engineering. Nobody. Correct? It's one of the very difficult skill to gain, very challenging, difficult skill to gain. So even if you know how to build models, if you don't understand data engineering, it will be difficult to implement. Anyway, thank you so much. You all take care. Bye.
Thank you.
Thank you, sir. Thank you.
Thank you. Bye.